Okay, welcome to video number 2, which is on index division, which is commonly referred to as index law number 2. Now, as an example, let's consider we have 3 raised to the power of 4, and we wish to divide that by 3 raised to the power of 2. Now, 3 raised to the power of 4 is effectively 3 times 3 times 3 times 3. Hopefully I had enough 3's there. And that equals 81. Now, 3 squared can be written as 3 times 3. And that equals 9. So obviously we can work out 81 divided by 9, and that equals 9. Or if I was doing the division of these, I would end up with 3 squared. Now, how do I get that? That's effectively 1, 2, 3, 4, and I need to take away 2 here. Now, we'll do a couple of examples, and hopefully that will make a little bit more sense. So effectively, if I was doing division here, I'll take my pen out, and I would cancel this one out with this one, and that one out with that one there. That is what I was trying to say. Now, index law number 2 effectively can be written as a to the power of m divided by a to the power of n equals a to the power of m minus n. So I'm going to move to the next slide, and I'm going to go through about 4 or 5 examples, and hopefully it makes just a little bit more sense. So bring the pen up here. Now, first thing I do is check, do I have the same base? Yes, I do. Base of 7, base of 7. So my answer will also be the base of 7. Now, I have to the power of 9 over here, to the power of 4 over here. So that becomes 9 take away 4. So the answer there becomes 7 raised to, 9 minus 4 is 5. So that becomes 7 raised to the power of 5. So that is the answer there. So let's clear this one away, and I'm going to move on to the next one. So get rid of that one, and the next one is, now this time instead of using a number, which is a base, I'm going to use a variable, which is c. C is just an unknown number. So my answer will also be to the base c this time, and I look at the indices here. My index up here is 7, and index here is a 5, and because I'm doing a division, I need to subtract those two. So the answer becomes c raised to the power of 2, or c squared. Now I'll just move on to the next one here. So my next one is that one there, and I'll just clear what I've already done here. Now, this situation here where I have x to the power of 3, or x cubed, and I'm going to divide that by an x. Now, when you see an x or any number by itself, you can consider it to have an index of 1. So that will become x is my base, and, or if I want to rewrite this, I can think of it as x cubed divided by x to the power of 1, or that becomes x to the power of 3 minus 1, which will become x to the power of 2. Alright, hopefully that makes a little sense to you, and I'll move on to the next one here. Now you notice they're just progressively getting a little bit more complicated. So this time I have 2 different bases, a base of x and a base of y. Now, it's a little bit like eating elephants. We'll just do one piece at a time. So let's look at the x's first. So up here with my pen, now my x's. I have x raised to the power of 7 over here, and x raised to the power of 5. So that will have an x raised to the 7 minus 5. Now, with the y's. Well, over here, I have y raised to the power of 4 and y raised to the power of 3. So that will become 4 minus 3. Now I can write that as simplifying x, 7 minus 5 is 2, and y raised, now 4 minus 3 is 1. Now, I don't need to have this 1 here. I can actually drop that 1 and just have x squared y. And that's the answer that I'm looking for there. Now, let's just move on to the last one. So I'll get rid of that question there and bring out the most complicated one that I've got. And just clear these annotations. Now, again, we just treat it one bit at a time. So the first thing is we look at these coefficients, the 12 and the 4. So this will just be 12 divided by 4. So the first bit would be 12 divided by 4. Right. So that's the first bit I'm looking at. Right. Then the next bit, right, look at the x's. I have x to the power of 3, x to the power of 2. So I'll write my base of x here, and 3 minus 2. Now, let's look at the y's. I have a y to the power of 20. It's getting quite large. We can fit all this in, and I'm going to subtract a 10. So my answer will become 12 divided by 4 is 3. X, now to the power of 1, or I'll just x, y to the power of 10. Now that is the last example that I'm going to deal with. So let's just go back to the original slide that I had here, which is when I'm performing index division, or if you want to think of index law number 2, a to the power of m divided by a to the power of n equals a to the power of m minus n. So when we're performing division and the bases are the same, we can subtract those indexes. So hopefully this slide has given you a better insight into performing index division. So that's it for now. So